Hey guys, welcome to part 13. I've been pulling some help from some of YouTube's heavy hitters, and I compiled a list of suggestions of stuff that might be wrong with this Sylvania chassis for the reasons not having negative bias voltages and stuff. The list is taken from 3 different members of YouTube. The first suggestion that might happen here is one of the electrolytic capacitors wired in backwards, which would be these 2 jobbies right here, these 2 47 microfarad 160 volt electrolytic capacitors. And the answer is no, they are not. This is a positive, the blue wire is positive, the red wire up here is the other positive, and the black right here is the common ground. And that black is jumpered from here to here, and our negatives are hooked up correctly. So, number 1 question, no. Number 2, on the 35W4 rectifier tube, there's a 25 ohm resistor coming off its anode. Okay, well that's all good and fine. We show it right here on the SAMs. It's right here, number R11. And R11 shows that it should be a 25 ohm 1 watt resistor. And we look over here at the writers, and the writers even shows it right here. 25 ohm resistor R11 comes down and connects into what I believe is supposed to be pin 6. It's hard to read that, but I don't know if that's what it is. It might be 5 or 6. Alright, well it says that resistor's there. Let's go look in the chassis and see if it's there. No, there is no 25 ohm resistor coming off of any of these leads on this rectifier tube. The only resistor that's anywhere close to that is this brown, black, yellow 100 meg ohm. It sits up here. It goes between the IF cans and ground. That's it. There's no 25 ohm resistor right there on that rectifier. None. Even though the drawings all show it. And I didn't take it out of there. It wasn't there to begin with, or I would have replaced it. And I remember actually ordering resistors for that to replace, and then I found it didn't have one. Okay, does not have. Well, okay, check that off. Next suggestion is the IF transformers cross-connecting. I'm not really familiar with that term. I don't know what they mean by that, but of course they're going to cross-connect if that's what they mean by wiring, because off of pin number 6 right here on the 50C5 we have 90 volts that comes over and goes into the IF transformer. It in turn jumps across to the other side of the IF transformer coil and goes right over to this side of this transformer, and then jumps across that capacitor to the opposite side. That's how it was factory wired. So I guess in a way they do cross connect. They do supply voltage from one to the other. I suppose that's the way it's supposed to be. I took reference photos when I started all this, and I went back and reviewed them. It never hurts to have this stuff. Here's one of the leads I'm talking about. Comes down and goes around and goes right to the other one. Here's a view on the other side. Right here to here. Comes out the other side and goes right down to here. So they do cross connect. They are wired together. So if that's what they mean by cross connecting, well, I guess that's in a way it does cross connect. The C14.47 cap. It's we need to test that and make sure there's no short between whatever it's connected to and ground, which I'm supposing is the rectifier right here. It goes over to the local oscillator, goes from the local oscillator down to ground. I haven't checked that yet. That's on my list of stuff to do. I will circle that because that needs to be done. Connected to B minus, make sure it does not read shorted. That needs to be done. Check the IF cans for short to the can through the coil windings. Everything in here, I hooked a lead to the can top, on top of the chassis down here, and touched every pin on them. Nothing's shorted, so we're good there. So, no. Pin 7 on the 35W4 should have 117 volts. Well, when we were operating it off our variac back here, which I was inputting around 110 volts. We were getting about 108. So I'm going to check that voltage, but as far as I know, that's okay. Now, it's been suggested to me by more than one person. Matter of fact, there was another person that weighed in on this watching one of the videos that I did not ask, and I value his input. Thank you very much. Is to check all components of the 12AT5 and the 12BE6. Especially your 12BE6, because that is your oscillator mixer tube. That's the one that sits out front here that was dark. That's this one right here. And I'm going to pull out the tube tester before this video is over and done with, and we'll compare this one to the new old stock GE I have in there right now, which is a 12BE6 as well, but it's brand new. It tested great in the tester, but I'm going to put them side by side and I'll show you what I mean. Another suggestion to check was for shorted plates in the tuning capacitor. Well, I took all of them. You can get a small piece of paper between every one. None are combined, none are pushed together. So that option's ruled out. Now I want to show you guys something else here. Let's trace through this thing from the line cord coming in. The line cord comes up to the clock plug. One side goes to this side, the other side goes here. Now when our clock plug is plugged in, which is that plug right there, it's a 3-conductor plug, you don't have power between these two pins unless the clock's plugged in, or in my case I have a jumper wire in between there. Once power comes in, goes to the terminals through the clock motor, one side of this comes out and goes directly to the appliance plug down here. It comes back out and it goes right over to pin 3 on the rectifier tube. The other side comes off of this right here, this point on the clock motor plug, and comes right down to pin 5 on the rectifier tube. From there, it goes through a 0.05 capacitor, 400 volts, and goes over here to the local oscillator. From the local oscillator, it goes through another 0.05, 400 volts, down to ground. This other lead right here, comes off and actually goes back to pin 1 on the rectifier tube, off the oscillator. There's a lot going on in that spot, and that's the way it was tied when I first took this radio apart. This connection here has a lot of wires, and same with this. This is a common ground. Pin 1 on this 12BE6 is where I was pulling 87 volts at, which should be a negative voltage. Pin 2 should be 90 when it's tied between this connection here and your common ground. Should have 90 volts plate voltage on there, which we do. We have plate voltage through all the tubes at 90 volts. And from over in here off of this rectifier, we have another lead, a blue lead. It comes back across, that goes to one of our filter capacitors. And off the 12BE6 right here, we have another red wire off of pin number 6 that goes over to our other electrolytic filter capacitor. And this is our common ground, which goes right back to the chassis. So what do we have going on here exactly? Well, I've been told, like again, to check that 12BE6, make sure everything's good in it right here, because there's no reason why you should have two positive voltages close to 90 volts coming in on connection 1 and 2. That doesn't make no sense to everybody I've asked. 2, check all wiring connections, make sure nothing's connected wrong, nothing's poorly soldered, everything's of good quality. Go back through, if you have time, which you should, check all your capacitors, make sure everything's good to go. Things that shouldn't be shorted or grounded, make sure that they are grounded and not shorted. And 3 is to go through and check all the wiring associated with this plug right here, being this is the one that messes with our oscillator right here. So what I'm going to do next is pull out the tube tester. We're going to compare the old 12BE6 with the new 12BE6 that's in here, and we'll go from there. I'll get a spot cleared off here on the bench and we'll get to it. I've set up the tube tester to the correct adjustments for a 12BE6, which is a filament voltage of 12.6 volts, circuit selector of C, and a load of 6. We'll plug into terminal 3 here with our tube. Filament's lighting. And here's our new old stock. And that tube only reads about 40%. It's slowly still coming up. Okay, well that's a definite fail. Let's go over to leakage. Well, it shows we have no leakage. That too is definitely number C is the one that counts according to the book, according to the listing for a 12BE6. So, according to the tester, that tube is definitely crap. Let's unplug him. With the same adjustments set on the tube tester, let's plug in our brand new 12BE6 filament lighting. Away we go. That one reads about 80% life. Let's set it over to leakage. You can see we got a little bit of leakage. The light's just barely lit right there. A little bit of leakage on that one too. But it tells us that tube's good. Very little leakage though. Don't know why a brand new tube would be leaky unless it's not a brand new tube. It's just one somebody set back that was out of something else they stuck in a box, but who knows. Let's go over to leakage on this old one. Sure enough, we have the same thing on it. On the exact same, on B and F, we have the same condition. It's showing leakage. But in the C range, still showing about 40%. So I don't rule out that that ain't a bad tube for one, because it's not giving a very good reading on the tester. Which, since I have recapped this tester and did a little work on cleaning the controls, its performance is greatly increased. I also noticed too, if you take a little bit of emery cloth or like a Brillo pad and clean up these pins on these tubes, you get a lot better results, especially in this old thing, because it's 60 some years old. Maybe these connections down in here have gotten a little corroded and whatnot, but it seems to boost the performance a little bit better by taking the time and cleaning them pins, which these two I did before we did the video. So there's our Sylvania 12BE5. Right beside it is a GE 12BE5, or 12BE6, I'm sorry. So guys, passing along that little bit of information, I just wanted to let you know what I found out since the last time I put a video up, which is a little over a week ago, that haven't given up hope on this thing. Just haven't had a whole lot of time to work on it. Things have been kind of hectic. This is just a part-time hobby that I have. You know, I might spend about 3 hours a week in the shop on certain weeks, and the other week I might spend a whole weekend in the shop, which is maybe the case this weekend because it's supposed to be rainy here in Ohio. So I might have some time tonight and tomorrow to mess around with this a little bit more. I'll be curious to know exactly what is wrong with this once I find it. I'll probably feel like a real dumbass because it'll probably be something so simple. But I need to check these capacitors over here in the power supply. Make sure nothing's shorted the ground to shorten out the bias voltages. And now I know that tube's good, I can put it back in. and a few other little checks that had been passed along to me to find a signal tracer, which I do have this Heathkit T3, but I don't have a probe for it. Bought this at that antique swap meet here about a month ago. I don't have a probe for it. This uses an RF probe of some sort. So, once again, old Tim over in Pennsylvania, AM station engineer. I need to have him on speed dial like John has his mentor on speed dial. Talk back and forth quite a bit sometimes, multiple times during the day. And I want to show you what Tim passed along to me. This is a website right here out of Ohio about building tracers or probes for some of these signal tracers, which, you know, mine's a variation of one of these two. I think it's more like this one. Of taking a pill bottle and building a probe for these. A lot of these, all they really need in the circuit is like a diode and a resistor, I think. Or a capacitor, I mean. To look through here for the proper one for the T3. That's for the accurate. That's kind of what they look like when you're done. Very simply built. This is for an ICO 147A, PACO Z80 Night signal tracers. Here's for a Heathkit T4 or IT12. And here's the T3. Basically all you have is your lead, coaxial lead back to your signal tracer. You have a bolt for a probe. This is your pill bottle, the outlined pill bottle. It uses one resistor, which is a IN34, a 1 meg resistor, a 47K resistor, and a 0.02 capacitor. And that's your signal tracer. And to build one of those wouldn't take much time. I think probably the only thing I don't have is the diode. I'd have to go shopping for that. So I'll have some time later this week if I can't get this going by then. 4th of July is coming up. Definitely have Thursday off from work. Friday's kind of a crapshoot right now because everybody's wanting the day off, and if there's not enough people there, they might just wind up giving us that Friday off. Depends on how deep the pocketbook is that day, I guess. So we might have a 4-day weekend next weekend, and if we do, I'm going to dedicate some serious time to this if I don't have it figured out before then. So I'm going to go ahead and put this video up. It's Saturday, and it's about 11 a.m. So I hope to get some positive feedback back, guys. Thanks for watching, and more to come later.